So we're going to give you definitions today for all the terms you're responsible for test 2. The good news is the list is smaller than the list from test 1. That's the good news. The bad news is, right, yeah, there were 2 million, now there's 1,900,000. No, there's not that many. So the first definition, the bad news is it's not in the book anywhere. I gave it to you in class. It's the definition of probability. I really didn't see anywhere where they actually defined it for you. I know I defined it for you in class. So therefore you have it in your definitions. In case you don't have it in your definitions, it sounded something like this. Probability. A numerical value between 0 and 1 inclusive, which represents the likelihood an event will occur. Probability. It is the definition of probability. In your notes, it should read something like this. A numerical value between 0 and 1 inclusive, which represents the likelihood an event will occur. For those of you that wrote it down when I first gave it to you on the very first day, I'll bet you a bagel that was exactly the same definition I gave you word for word. Okay? Love my bagels. All right. Especially when I win them. It's even better when you win them. Page 135. We started definitions in the book. Here you go. Page 135, event. Page 135, event. Page 135, simple event. Page 135, simple event. Page 135, sample space. Page 135, sample space. Now, going to page 136. Going to page 136. You have several definitions in bold. Starting with the first one. Relative frequency approximation for probability. Relative frequency approximation. Moving from page 136 down the page to classical probability. Okay. And lastly, on that same page, page 136, subjective probability.
What was the one before that?
Classical.
Classical, correct.
Okay. Subjective. As you look over to the next page, page 137. As you look over to the next page, page 137. Law of large numbers. Law of large numbers. Page 137, law of large numbers. Now we're going to skip ahead. Now we're going to skip ahead to page 140. Now we're going to skip ahead to page 140. Everybody okay? All right, page 140, complement. Complement. You'll have seen this notation here on a handout I gave you, I hope. I hope you recognize that notation. Complement. You're going to like this jump. From page 140 all the way up to page 149. Where we actually talk about compound events.
From what page to 149?
From page 140 to 149.
Okay.
Page 149, compound events. Page 149, compound events. Moving ahead to page 151. Moving ahead to page 151. Scrolling down to the bottom of the page. Yellow box. Disjoint. Also known as mutually exclusive. Now you remember in class I referenced it as mutually exclusive. The book references as disjoint. They're the same terms.
Which one would you call it on a test?
The question is, which one would I refer to on the test? Most likely mutually exclusive.
Okay.
Although I retain the right to use both. All right, now another kind of big jump. Page 157. Going from 151 to 157. Sorry to keep you awake over there, partner. Looking at two terms, independent and dependent. Independent and dependent. Those are two terms. Now, a lot of people apply circular reason to their definitions of independent and dependent. And by circular reason, I mean this. I would say to somebody, well, what's the definition of independent? And they go, well, you see, two events are independent as long as they're not dependent. And I'm like, okay, that makes sense. So what's dependent? Well, two events are dependent if they're not independent. And so all they do is just keep running around in circles. Okay? That's not what we want to do. You have to be able to define one of them. The one we always choose to define is independent. Okay. Page 169. Page 169. Conditional probability. Conditional probability with an emphasis on this notation. You need to be able to recognize this notation. Sorry, Donnie, I'll pull it up so you can see it a little bit better. Here. There. All right. Recognize that notation. Where do you see that notation at? Page 3, test 2. You're going to see that notation. When you come up and you ask me, what does that notation mean? What's my answer? -5. If you have to ask me what that notation means, you ain't getting it right. Okay? So, you didn't want 100 anyway. Alright, conditional probability. Now, massive jump. From 169 to 197. 169 to 197. Got a lot of words here. Excuse me. Random variable. Probability distribution. Kind of piggybacking off some of the definitions we did last time. You remember discrete and continuous data? Well, we also have discrete and continuous random variables. So let's go ahead and look at those again as well.
What were the first two?
Good question. Random variable and probability distribution.
And the page?
It is on page 197. Okay. Looking at page 201. The whole point behind the game that we played last time was to teach you about expected value. Trying to learn about expected value.
What was the one after discrete?
continuous.
Okay.
The whole point of the game last time wasn't to give away points, it wasn't to have fun. It was that you learned about expected value. You should know what expected value means. It's on page 201. Okay. And lastly, on page 210, right here. Gold yellow box on the bottom of page 210. There are 4 requirements of a probability distribution. There are 4 requirements of a probability distribution. I will tell you this. For those who remember the hint I gave last time about test 1, I said every test I've ever given has had big N and little n on there, yes? I also told you that there'd be people who didn't know that, yes? Okay, well, it was on there and I was right. Every test I have ever given involving test 2, at the bottom of page 1, I have asked the following question. List the 4 conditions of a binomial distribution. They are important. List the 4 conditions of a binomial probability distribution. They are important.
They have to be in order.
No. That's a good question. The question was, do they have to be in order? No, and they don't have to be word for word either. But you better get the gist of it.
So you don't have to know the parts in the parentheses that explain it further?
No. You just right. The question was, do we have to know the parts that are in the parentheses too? No. You just now got to know the part that's in front of the parentheses. Okay. Every test 2 I've ever given has had at some point on the first page, what are the 4 conditions of a binomial? I would not suspect this would be any different. With that being said, that will conclude your definitions for test 2.